Sir. Hope you're well. My name is Njabulo Zondo, student number 15817873. So today I'll be taking you through my presentation on the upgrade of P77 in Edududu, KZN. So basically, this is my project resubmission because for the first project I got 40%, and I've actually made amendments to the project itself as per the comments that you directed were made on my student portal. Um, Next page. So the project overview. Project overview. The objective of this project is the upgrade of 4 kilometer gravel road P77, namely, to a 4-lane divided provincial road in the province of KwaZulu Natal. And the purpose is practical experience in road alignment and pavement design, as well as the use of the geometric design softwares and in conjunction with the South African codes. Standards basically, of which number 3 here, the standards used were SANDO and TRH as well guidelines for geometric and pavement design. And then the location of the site is the Umdoni local municipality, the Ugu district, Ward KZ 212. And then this is basically your route description. So this is showing you your the start of construction to the end of construction. We've considered our alignment. So the terrain is mountainous with tight alignments, the gradients, and then the community impact. It serves like 14 schools, 2 clinics, businesses, and used by public users, agricultural, as well as private vehicles. And then the environmental and site details. So the climate is hot with a precipitation of 858 mils annually, with the verdness number of N less than 2. And then the vegetation is dry coast, hinterland, grassland, vulnerable with invasive species. And then the investigations that will be required. So the first one will be the environmental impact assessment. And then the second one is the topographical survey by a registered surveyor, as well as the geotechnical investigation by a registered geotech specialist. And then the geometric design. So the geometric design is as shown. So design speed as per TPG3700 is 70 kilometers for the class of the road. And then the minimum radius for of which was road class 3, 70 kilometers per hour. And then the minimum radius is 160 meters as per TRH17. And then the vertical alignments of which we were requested to generate an Excel spreadsheet for a calculation of a vertical alignment. So maximum gradient for flat is 5.5, and then for rolling is 6.5, and then mountainous is 7.5 as per TRH17. And then this is the spreadsheet, of which is very user friendly. So the input is in yellow, and then the output is in green basically. And then there on your site, you see it gives you like the type of a curve of which it's a crest or it's a sag. It's a very user friendly spreadsheet, so you can just go through it. You'll see. The pavement design. So the method we're using a TRH4 catalog method. Considering ES10 traffic class, category B road. And then the subgrade has a CPR of 7 to was assumed to have a CVR of 7 to 15%. With class SG2, so you have a subgrade with 150 mils of G7, G9 layers, and recompacted, rip and recompacted 150 mils G9. And then your traffic is 3.5 million E80s per lane per day, 20-year design period, and then like 2 to 4% growth. And then recommended structure: flexible pavement, cost effective and durable. There is the reason for this. So it's 30 mils asphalt, 80 mils graded cross stone, and then 30 mils cement stabilized gravel, 150 mils G7, 150 mils G9 subgrade. And then in terms of drainage now. So in terms of drainage, just like the sequence of drainage, so what you do is you get your catchment area, your longest water course using global map, rainfall data using rainfall estimation program, and then you get like your floods using utility drainage program, Sinotech basically. Hydraulic opening sizing, you use the drainage manual 6th edition, and final check is using HY8, which is a free software. Basically, the HY8, it actually is where you check if the freeboard is met, the freeboard of the head water depth being less than 1.2 D, of which D is actually the height of the opening of the culvert. And then drainage, so this is actually a layout. This layout actually shows you the positions of the culvert. So basically from culvert 1, 2, 3, 4, 5, 6. So these are all the positions of the culverts, bounded by the start and end of the construction. And yeah, this is it. So the standards, as shown, standard drainage manual 6th edition, and what you do is you use the 1 in 20-year flood frequency to get your design flood, and then macro drainage, it's consider rational method, catch water banks, inlet control pipes, and then your freeboard of 1.2 D. And then micro drainage to side drains, cabs, V drains, gable structures for erosion protection, and all that. And then your key facilities. So it's pipe culverts, of which are 750 to, of which range from 750 to 1.2 100 1,200 millimeter diameter pipes, and then box culvert of 1.2 by 1.2 meter and a 3 meter by 3 meter box concrete culvert. And then the costing of the project. Costing itself, so the road construction is about 15 million. Culverts, the structures, the drainage structures basically about 5 million, of which totals to 20 million, excluding vert and contingencies. And then the software is used. Uh, Generally, you'd use Global Mapper, Rainfall Estimation Program, Utility Drainage Program, Sinotech, HY8, and that's just for your culverts and drainage basically. And then now Civil 3D for geometric design in conjunction with AutoCAD as well. And then this is just like a screenshot which was recently taken, you know, showing like basically like the uploading of the CSV file where you're gonna create your points, and then from your point you do like a surface creation after that. Um, and then conclusion. So conclusion. So the benefits of going through with this project, as soon as the road is paved, it's finished. I mean, there's going to be economic growth, job creation, skills training, and improve mobility, reduce accidents, and lower vehicle cost. And this is definitely going to attract investments via enhanced infrastructure. And then the outcome is safer, durable road supporting community and economic development. Thank you so much, Joe, for the opportunity. This was very helpful. I learned a lot, more especially the use of Civil 3D and the design of roads as well. Thank you so much. I appreciate this opportunity, and take care.